Hello and welcome to this short introduction to Brachylog. Brachylog is a declarative logic language which is based on Prolog, and it is intended to write short declarative programs. In this video I will show you the basics of the language and the mindset you need to program with a declarative logic language. We will take the example of a string palindromization program as our first code to program in Brachylog. Brachylog is usable on Try It Online, which is what I'm using here, at this address, tio.run/nexus/brachylog2. In Brachylog, we describe relations between things, instead of chains of operators to implement an algorithm as we usually do in imperative languages. In Brachylog, most things have two arguments, an input argument and an output argument. For the main program this is also true, and for the main program the input argument is the question mark and the output argument is the period. So our very first piece of code here only says that the input must be the same as the output. And so if we try with an actual input such as the string test in between double quotes and the output which is put in the argument part in Try It Online, an output of z which is a variable name, if we run this code, Brachylog answers that z must be test, which is actually what we were describing. In Brachylog there are lots of existing relations which are called built-in predicates. One of those existing relations is the relation reverse, which is denoted by this double-headed arrow symbol. And so what we're saying here is that the output must be the reverse of the input. So if we have an input of test and a variable output, Brachylog will tell us that this output z must be set, which is the reverse of test, as expected. Now keep in mind that this is a relation, so we can actually run this code with, say, an output which is already set to set, and if we run that, Brachylog will tell us true. What we are describing here is true, that test is the reverse of set. And if we do something like this, it will tell me false. Set is not the reverse of test, as expected. But we can also run the output as test and the input as a variable. This is a relation. There is no predefined directionality to this reverse relation here. So if I run this, now it will tell me that z is set, but z this time is the input, not the output. So as you can see, these are really relations and not operators that take a certain number of arguments and produce a result. These works in any direction. This is not true for all predicates in Brachylog, but for most it is, and this is very useful when programming. Another example of built-in predicate that exists is concatenate, which is the letter C, lowercase. So if we put an input, say, of a list of ABC and DEF, this is a list between square brackets, and with a comma to separate elements, and we put back a variable, say z or say a, for example, as the output. Here we are describing that the input concatenated into one result, which is the output, must be true. So if we put that as input, then we expect the output to be the string ABCDEF, which is exactly what Brachylog will tell us, that A, our input, is ABCDEF, which is what we were expecting. Now we have all we need to describe a palindromization algorithm. So say I want to palindromize the string test. The expected result I want is this string here, test set, which is read the same in the forward direction and the backward direction. Um, so to do this, we are not going to describe what the computer should do. Instead, we are trying to describe the relation between those two strings. And the relation is actually very simple. We just need to tell that, first of all, this output must be the same when reversed. So we know the reverse relation, which is this arrow here. So if I write something like this and ignore the input for a moment, what I'm saying here is that the output reversed is still the output, which is what we want for a string to be a palindrome. So this is cool. Now how can we describe that this output is actually constructed from the input? Well, this string here contains the input here, test, and something extra at the end. So we can say that the output is the result of concatenating the input with another string, say s. So this column here is constructing a list input and the variable s. I don't know what s is, it's just a variable. So typing this question mark column s c really means that, and the period after that means that the output is the result of concatenating the input with a string s, or anything that is called s. I don't know what it is and I don't really care. And after that I'm telling that the output when reversed is still the output. Now when I run this with the input test and a variable output, it will tell me that z is in fact test set, which is what we were wanting. It is a palindrome which is constructed from this input test. As usual, I can set the output and check that indeed it is true, that this output is really what we were expecting. So this is our very first program in Brachylog, and as you can see, it is quite short, and we are only describing what we want from the input and our output, the relation between those two things. We can make this program a bit shorter, because in Brachylog, this main program has the input at the very beginning and the output at the very end implicitly. So I can in fact remove this last period and this first question mark, and this still does exactly the same, as you can see. Now a brief example of how you can do more complex things in even less characters. So this palindromization program is good for things like this, but if I put an input of bonobo, for example, and run it, it will tell me that the palindrome for bonobo is bonobonob, sorry, which is correct, but it's not the shortest palindrome you can do with this string. We can see that if we put an extra O at the beginning, we get the same thing, obonobo, which is a palindrome, and it is much shorter than this one. So how can we describe this kind of palindromization? So this is palindromization where we can insert characters everywhere, and this is actually even simpler to describe. So if I put back my input and my output just to see what happens, we still want that the output is the reverse of itself, that it is a palindrome. And now all we need to see here is that this string, this input string, is an ordered subset of this string here. So this one is contained in this one, no matter what in the ordering from left to right. But there may be characters in between to make it a palindrome. So I can use the built-in relation subset, which is a subset symbol, to say that the input is a subset of the output, and then the output is the reverse of itself. It's a palindrome. And when I run that, I will get that obodobo, which is what we wanted. And it works for more complicated strings such as stack exchange, and it will do insertions as it wants to get this, which is the shortest palindrome you can get from stack exchange, by doing insertions pretty much everywhere. So as you can see, if I remove the implicit things, in only 3 characters we can get this behavior, simply because Brachylog is about defining relations between things, and if the relation is very clear, it is very short to describe that relation, and we get much shorter programs than with imperative programming languages, where we have to describe actually how we have to do insertions to get the shortest palindrome possible. Here we are only describing that this string is a subset of this one, and that this one reversed is itself, and that's sufficient. So thank you for watching this video, and I hope it got you interested in Brachylog.